Good evening and welcome dear viewers of Channel 2 of Kuwait TV in your daily program, which covers all the events and activities such as social, art, technical, medical, cultural, sports and political, and hosts a lot of artists, athletes, doctors, engineers and intellectuals in various fields. Our first report is the American Society for Testing and Materials, ASTM. So let's check it out together.
Standards are all around us, applied to just about everything we use. Defined and set by us, some 12,000 ASTM International Voluntary Consensus Standards are supporting, influencing and ultimately improving the lives of millions somewhere in the world every day.
They mean that we can all be confident of the quality of a product, and that standards have enhanced and improved the way it works and even the way it was made. Standards also mean that industry and business are assured of a global level playing field in terms of costs and development, so that competing products are all tested and rated to the same standard, providing more accurate information to benefit consumers, whilst promoting the future growth of industries and economies.
ASTM standards harness the expertise and commitment of more than 30,000 members in over 140 countries. Individuals and organizations from industry, academia, governments, trade associations, independent consulting, and consumers. They use their good science, engineering, and judgment to improve performance in manufacturing and materials, products and processes, systems and services. Expertise and knowledge is shared openly so that our standards are relevant to the sectors to which they apply. This objectivity and international reach has made ours the trusted standards of choice worldwide.
We understand the positive impact our standards have on industry and business. Applying standards that represent leading-edge thinking from around the world involves advances in approach, process, and technology, which is why ASTM offers a range of value-added business services designed around the needs of our customers, helping them use standards easily and effectively. Together, they ensure our customers manage change well, maximize the effectiveness of the standards being applied, and improve their total performance.
Working across political, cultural, and geographical borders, our standards development process embraces the World Trade Organization Technical Barriers to Trade Agreement principles. Focused on achieving global consensus, we involve individuals, corporations, and governments in a massive range of activity, debate, and exchange of knowledge. Trusted for their market relevance, independence, and high technical quality, ours are the standards of choice for many global industries.
We believe in the power of standards to inspire and enable people and economies. Our global outreach programs increase knowledge and understanding about standards and promote communication between ASTM and our stakeholders worldwide. We welcome the next generation of technical experts, free and open to all, ensuring that our standards remain at the forefront of the next stage of development.
In all of this, we take the same approach as our very first members, who came together over 100 years ago to begin developing standards. We're ready to innovate. We value good sense. We're willing to share and be accountable. We help everyone have confidence in the things they buy and use. Understanding commercial needs and consumer priorities, we touch every part of everyday life, helping our world work better.
Welcome back. That was an amazing report. I'm here tonight with Dr. Anthony Bentivegna, ASTM expert. Hello and welcome to our show for tonight.
Hi, thank you for having me.
It's always a pleasure to have you here on the show. Can you tell us more about your background, where you studied, and the different certifications that you had?
Sure. So thank you for having me again. I'm excited to be here. So I'm a civil engineer from the United States. I have an undergraduate degree from the Georgia Institute of Technology in Atlanta, Georgia. And my degree is in civil engineering for my undergrad. I then went to grad school where I'd studied structural engineering and material science at the University of Texas at Austin, where I studied concrete and cementitious materials, and I gained the knowledge there for what I do today.
Very interesting. Can you tell us more about your certifications that you have?
Sure. I've recently become a professional engineer in the United States. I am now now licensed in many states across America, and I'm gaining more with every day. And I'm also certified in ASTM test methods, and I'm actively involved in the development of these test methods.
Wow, that's just amazing. Yeah. Can you tell us more about your work experience, since you have worked in different places around the world? Can you tell us more about that? Sure.
So my job is kind of split into two different things. I'm a consultant, and then I'm also a trainer and do training courses like the one I'm here for Kuwait. And as a consultant, I try to solve a lot of problems related to construction and building materials. So what I do is, I work for contractors and building owners to fix a problem with reinforced concrete if there's a problem in new construction, whether there was a mistake made with a mixture design, or whether a concrete structure begins to fail prematurely, like due to cracking or corrosion or other durability problems. That's
just a crucial job, I've got to say. Can you tell us more about your work experience here in Kuwait?
Sure. So the other part of my job is with training courses. What I do is I travel to different locations, and I provide training on different test methods related to cement and concrete. These cement and concrete training courses are used to characterize and evaluate materials that are used in concrete around the world.
Very interesting. And I believe you have next and upcoming different places that you're going to in training courses. Can you tell us more about those places?
Sure. So currently I'm conducting this 2-day course in Kuwait. After this, I'm going to Riyadh in Saudi Arabia. That'll be my first time to Saudi Arabia. I'm
Very
excited about that. And then after that, I go to Doha in Qatar, and we're going to be presenting at Project Qatar there. And that's a shorter course, but it will be a wider breadth of an audience.
That's very exciting. Can you tell us about the different places around the world that you've been to as well? And are those training courses differing based on the location you're at and the country you're at, or is it similar throughout?
Sure. Different countries always have a different interest. I will be in Brazil later this year, and we're going to be focusing more on concrete durability there. So there's a specific problem called alkali silica reaction. That's a problem between aggregates and cement. And so we'll specifically be speaking about different test methods for this, different repair strategies, and then also how to evaluate structures which suffer from this premature durability problem. And so in addition to that, I've conducted basic training courses that are just on cement and evaluating the cement characteristics. So those are other ones that I've also done.
Very interesting. Can you tell us more about ASTM and what is its main role?
Sure. American Society for Testing and Materials is a not-for-profit organization that develops standardized testing procedures and test methods for the evaluation of products and materials from around the world. They develop these standards so that we can evaluate the materials and try to improve the performance of materials so that they will last longer, they will be safe, and there's no failures that will hurt anybody. ASTM is really grown in Kuwait, and it's widely accepted here and in the GCC region itself.
Very interesting. And is it certain materials that you have at ASTM, or it's just specific materials that you're working for?
So, I typically focus on cement, concrete, and aggregates, the things that make up, concrete, the building materials that we see across the region every day and across the world. But they test everything from plastics to metals to steel to actual finished products like soccer balls or footballs, I guess.
Nice.
So
to make sure that everything is safe to use later on.
That's exactly right. You want everything performed to the same test method, so that way we can compare apples to apples. You have the comparison of the same, you can evaluate whether the material is good relative to another one, and that you're not producing a product that's inferior or that's poor quality.
Can you tell us more about the purpose of testing? Because you're telling us there are various methods and a lot of testing has to happen.
Right.
But what's the main purpose?
So testing, I would like to tell you that it would reflect actual field structures or field simulations, but that's not the case. We don't have a test method that tells you everything that a concrete structure is going to be exposed to throughout the duration of its life. So a lot of the purposes of test methods is just to determine the precision of the actual test method. Precision meaning that you want a test method to be repeatable, that different laboratories can perform the test on the same material and get the same result.
And how accurate are those tests so far?
It varies drastically. Some of the test methods, some of the older ones that have been around for a long time, they definitely have some variability and variability between users. So if you were to do the test versus whether I did it, we may get completely different results, even if we were both trained in it, because there's a lot of user dependency. I think the aim of ASTM, and when we go to conferences to develop the ASTM test methods, the aim of it is to make them so that they're not user dependent, but they also give you a precise result that's repeatable.
And with the advancement of technology, did that help and boost the accuracy of the testing methods?
Absolutely, we're seeing that every day. With new technology coming on the market, we're finding ways to implement computers, other electrical simulations, to accelerate test methods and to also make them relate to more of the real-world field experience that we're looking for.
And now, since you're here in Kuwait, I believe you're testing out the cement.
That's
mostly.
correct.
Yes.
That's correct.
So can you tell us more about the testing and what is it and how do you do it for cement specifically?
Sure. So we're evaluating all properties of cements, the training that we're performing. We start off by evaluating the cement by itself. We talked about the chemical composition of it, how we analyze it, how we determine what constituents are in there, and whether there's enough of the correct ones inside of it. We also evaluate the cement when it's mixed with water. When you mix water with cement, it hydrates. It's a hydraulic reaction. And so we evaluate the properties and the characteristics of the cement once it's mixed. And so we look for things like soundness. We look for whether it entraps air in there, because too much air is a bad thing for strength. It'll make you have strength.
And how would you eliminate all this different air if there was any air in existence?
So you would look at the materials that are in there. You would look at the chemical composition. Maybe there's a product in there that's not supposed to be, or an element that's in there. And so we'd have to look at when the cement was made and try to fix that, identify the problem and fix it. And then the other things we test for are also strength. Obviously, strength is a major thing when you're building a structure.
Definitely.
So we always want to check to make sure that it's a quality cement, and the #1 indication of that usually is through just strength testing.
Very interesting. Can you tell us more about the topics that you discussed throughout the conference and the training course?
Sure. So we talk about overall test methods, why we perform testing, what the test methods are used for. We talk about testing the cement by itself, the chemical composition. We talk about testing the material when it's mixed with water. Then we move over the next day, the second day of the conference, and we start talking about concrete, because cement is a constituent material that makes up concrete, one of the materials. And so when we talk about concrete the whole second day. So we talk about how to sample the materials. When you see a concrete ready-mix truck on a job site, when's the proper time to sample the concrete? How do you sample it? How do you move the materials around on a job site? How do you make the proper samples?
Yes, everything seems so accurate and well organized. We're going to see a report based on the ASTM.
Okay.
So we're going to check out the second ASTM Cement Conference and Workshop.
success, and following on the encouraging feedback of the inaugural event last year, Kuwait Cement Company and ASTM have decided to launch the second two-day training workshop. The aim is to create an annual educational platform to related professionals, both in the governmental as well as the private sector, that will help to further raise the quality standards of cement and concrete testing in Kuwait. In this context, we are extremely thankful for the ongoing support of the Ministry of Public Works, the Public Authority for Housing Welfare, the Public Authority of Industry, the Ministry of Defense, as well as the Kuwait municipality. Moreover, we are glad to announce that the Kuwait University and KISR agreed to join the conference as our academic and research partners. I also like to mention the Kuwait Society of Engineers and our media coordinator, Bentivegna, for their active support. Kuwait TV is our official media partner of this event. Finally, ASTM for their technical support and ongoing guidance. This conference wouldn't be possible without the generous contribution by our sponsors, Kuwait Cement Company and Kuwait Cement Ready Mix Company. Therefore, I would like to express our special appreciation to Mr. Ali Al-Kandari, the Marketing and Sales Manager of Kuwait Cement Company, and his entire team who are with us this morning. Many thanks once more to all of you for coming this morning, and without further ado, I would like to invite our first speaker, Engineer Mohsen Abdelensi, the Assistant Undersecretary of Planning and Development Sector at the Ministry of Public Works.
Welcome back. We're continuing our talk more about the ASTM and the concrete and cement here in Kuwait with Dr. Anthony. So we were discussing the audience, like who were the audience of the conference themselves. Can you tell us more about that?
Sure, absolutely. You know, it's a really diverse audience, and that's what makes it so interesting. We get representatives from the government. We get engineers that attend these conferences, technicians, chemists, contractors, people from all different areas of manufacturing cements to implementing it and making concrete in the field.
And why do you feel it's important for everyone to know more about the testing? Because sometimes the testing is done from like one perspective or department of the company, but we're seeing that a lot of people are getting involved. Can you tell us more about that?
That's a great question. Yes, so it's very important for everybody to understand the importance of the testing, because, you know, as a laboratory person and a laboratory engineer myself, I know what the impact is of, you know, changing little things about the material itself and how it'll affect the long-term performance of a structure in the field. But if, you know, a contractor doesn't know if I added extra water to a concrete mixture, what the implications of this are, then then he could have just jeopardized the service life of an entire structure. So having a diverse group like public officials who write the specifications and make sure the specifications are what set the requirements for the mixture designs and for the structures to make sure that they have a long service life, having contractors, having technicians that are actually performing the test so that they're performing the test properly, so that way we can compare results across the different labs.
And are all the requirements similar for cement, or does it differ based on the type of results you're going to see or the construction?
It differs more on the construction and the location of a structure. So if a structure was going to be built in Kuwait, the region's not worried about freezing and thawing, so you don't have to worry about damage from snow.
More about heat,
a lot of heat.
Yes.
And you worry about salt coming from the the sea, coming off the sea. There's a lot of salt, and salt's bad for rebar, that steel reinforcement that is inside of concrete. So there's a lot of concern with that. So we would worry about more of those things instead of worrying about.
And how would you make it different based on the fact that it's hot or cold or the region? Do you add specific things, or there are certain tools that you need? Can you tell us more about this?
Yeah, absolutely. So, I mean, we would do different tests. So if the concrete was located in a cold weather environment, there's testing that would show whether the concrete is resistant to freezing and thawing environments where the concrete cycles between cold and hot weather. In climates that are exposed to chlorides, like from the sea, or if you had like a pier out in the water, we would do testing of the different we would do testing to test the permeability of the concrete. And then we would also add in different materials. So there's supplementary materials that are added into concrete that improve the durability of the...
Can you name us some of those different materials that could be added to cement?
Sure. So one of the most common ones in Kuwait is ground granulated blast furnace slag, or slag cement.
And how would that help improve the construction in the end?
So when you add this to concrete, it changes the hydration products that form inside of concrete.
Okay.
And it changes the permeability, so there's less voids and less air, and that means it's more difficult for salt to get into the concrete and lead to corrosion of the concrete itself. So it changes the permeability of it changes the hydration, and it also changes the strength, typically increasing the strength of the concrete too.
Very interesting.
Yes.
Can you tell us more about the different types of cement?
Sure. Yeah, there's ASTM C150 is the standard test method for characterizing cement. There's 5 different types of cement that are generally associated with it. They're numbered 1 through 5. Each of these cements have different uses and applications.
Can you tell us more about those uses and different applications? And does it differ, because you said different locations, different temperatures? Is that the case as well, where you have the different cement as a whole?
Yes, so there's type 1 is a normal general use cement, and you would use it on roadways and sidewalks pretty much anywhere.
Okay, something we'd see around
Kuwait City, around in the United States. It's the same type of cement. But in like types 2 and 5 are resistant to sulfate, and sulfates come from groundwater and in soil. And actually, Kuwait has a high sulfate content in their soils.
So we'd avoid using 2 and 5.
You would want to use them. You want it because they're resistant to it.
Okay.
So you would want to use those. And then like a type 3 cement has high early strength. So if you wanted to do a rapid construction project, you would use a type 3 cement. Or a type 4 cement has a low heat of hydration. And so you would use the cement in large placements, like in a dam or in a large foundation in a building or something like that.
And does the cement differ based on like homes and houses as to, like, say, malls or big towers that we'd see? So
in a home and in a high-rise...
And which type would it be? Like?
So probably be just a typical type 1 cement in both. Okay. You would use but it's the way that it's used in the concrete. In a high-rise tower, you might have more cement in there than in like a typical home. And then you would also have a lower water content. If you put more water into the mixture, it'll be less durable and have more potential for failing prematurely. So it's the same material, but just used in different ratios is essentially the answer.
Yes, that brings me to my next question, which is, like, how do you improve the durability of cement itself?
How do you can improve the durability in a number of ways. By doing the proper testing, obviously, to make sure there's nothing in there that's not supposed to be present, and that everything is in the right ratios that are supposed to be in there with the different chemicals. You can improve the durability of concrete by lowering the amount of water that's added to the concrete itself. You could do testing to make sure there's not any interactions between the aggregates, the rocks that are inside of concrete, and the cement themselves. This is a very important step that can lead to a lot of failures. And then you can also have an understanding of what type of environment you're placing your structure in. These are all things that...
And how does the environment help, like, differ? You said weather, that could go about, and the size and durability. Is there other factors as well?
Yeah, weather could also affect the potential for cracking. So in hot weather or in windy weather, it can lead to early age cracking in concrete. So if we always see cracks in concrete all over the place, and it's probably because somebody didn't cure the concrete properly.
Is it always the case that we will in the future see this cracking, even though you have the testing, or if you have the testing done, perfectly done, then you won't see that in the future at all?
So we can try to minimize the amount of cracking that occurs in the concrete. If you do the test, if you get the right materials in the concrete, if you do the right curing procedures, and then you also place the concrete and construct it in the proper manner, and then it's not abused. There's proper maintenance on the concrete as well.
Very interesting. And can you tell us more about this concrete and cement? Is there some sort of correlation together? Like if you had the testing done here correctly, would that affect or the concrete itself, or vice versa? Like if you had something missing out, the concrete wasn't working well and the cement was working well, in the end, would it be a good result, or do you need to have both done perfectly?
That's a great question. So you essentially need to test both the cement by itself, and then you also need to test the concrete. This is to evaluate if there's any interactions between the cement and the aggregates and the other materials that are inside of concrete, to make sure that there's no anything that will cause any concerns. So if you just mix it all together and then you test the concrete, well, you may have missed something with the cement that would cause problems with the actual concrete, and so you would eliminate that problem by testing both parts separately. So it's very important to make sure you're testing, the constituent materials and the actual final product.
Yes, very interesting. And how is all this testing based on the cement and concrete have an improvement in the construction building in the end? And is it the same case if you don't have the testing done? Would there be a big difference? Can you tell us more about this?
Yes, so if you didn't actually do the testing, you could be opening yourself up for a lot of trouble. We don't know what could be sneaking in and what problems we could be having in the future. So by doing the testing, we're making sure that we're not going to have any interaction problems, and we're eliminating a material failure. Now, if we didn't do the testing and there was a problem during construction, then we can't affect that. But you're eliminating at least half of your potential problems by making sure that you've eliminated the material failures. Now it's just up to the contractors and the construction crews to build a structure properly.
Yes.
And so that's the main point of doing the testing.
It's definitely the case, and I'm sure everyone wants to avoid all that hassle by doing the testing. Thank you so much, Dr. Anthony, for being here tonight with us.
All right, thank you for having me. It's been a pleasure.
We're going to cut to a break, so stay tuned.